This next example, students, is to show you how to identify the product of a sum and a difference, aka it's called the difference of two squares. Why do they call it a difference of two squares? Because look at the answer. The answer literally turns into a difference, subtraction, of two squares. Where does this pattern come from? It comes from when you take a binomial times a binomial where it's the same two pieces, but one's a plus and one's a minus. Again, difference. This one's different than this one, kind of, but they're the same two things. Oh my goodness, it's crazy. Again, this will never happen. You will never, ever, 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 never end up with an a squared plus a b squared. You'll never end up with a sum of two squares. Ever. This never, ever, ever, never happens. Never, ever, ever. Okay? So here's the shortcut. Okay, I can do the polybox or I could do FOIL. But as soon as you see, a plus 5 and a minus 5 and they're both x, you can go right to this shortcut. So I'll get to the shortcut here in a second. Okay? So if it's the same pieces, but one's a plus, one's a minus, let's do FOIL. First, outside, negative 5x. Inside, positive 5x. Negative 25. Look what happens, friends. They're going to cancel. I'm going to end up with an x squared minus a 25. Look at that. It ended up with a square minus a square, a difference of two squares. Anytime you see this pattern, it's going to end up being a difference of two squares. Okay, let's make a polybox. A squared. Okay, which one's negative? Let's do, you're the positive, and you're the negative 8. I almost messed it up. Careful. Negative 8a, positive 8a, canceled, negative 64. Look at this. A squared minus a 64. Difference of two squares. So now that I've done it slow, I'm going to show you the shortcut. As soon as you see it's one of these, you can say it's one of those. Okay? So I got a 3y plus 1 and a 3y minus 1. It's the same two pieces. One's a plus, one's a minus. So I know my answer is going to be a difference of the two things squared. 3y squared is a 9y squared, and then 1 squared is 1. There's my answer. This whole thing would turn into a 9y squared minus 1. Don't believe me? Make a polybox, prove me wrong. I guarantee you these two things would cancel, and you're left over with those two pieces. Okay, difference of two squares. 4a plus 5c, 4a minus 5c. Weird, it's the same two binomials, but one's a plus and one's a minus. It's going to end up as a difference of two squares. So all I do is I square the first piece, and then I square the second piece, and it's a difference of the two squares. 4a times itself would be a 16a squared. 5c times itself would be a 25c squared. That's it. That's all. I'm going to go ahead and slow this one down and prove you that I did not make the mistakes. Okay, 5a, there we go. Maybe I should write it down right, 4a. So 4 times 4 is 16. A times a is a squared. 4a squared is a 4a times itself is a 16a squared. Negative 5c times a 4a would be a negative 20 ac, alphabetical. Positive 4 and positive 5 is a positive 20 ac. When you combine those, they're gone. Negative 5 times a negative c is a negative 5 times a positive 5 is a negative 25. C squared. There you go. So there's your two pieces. That's what's going to happen, friends. When you have the same two binomials, but one's a plus and one's a minus, like the same two ingredients, but one's a plus, one's a minus, these squares will always cancel. The FOIL, the O and I, will always cancel. So you're left with the first and the last. First thing squared, last thing squared. Weird. Okay, that's the pattern. Okay. That's about it. That's how you find the difference of two squares. It goes really, really fast. Again, I will not stress this enough. I cannot stress this enough. If you don't understand the shortcut, if you can't just look at this and then in your mind skip to the shortcut, this will always work. Okay, I'm going to show you some mental math uses here in a second.